Okay, let's give you guys a definite integration problem. So integrate 10 to the power 5, integrate 10 to the power 5 from 0 to pi over 4. So press pause and have a go. Okay, so to do this, let's use a reduction formula. But turn this, so instead of doing the definite integral, let's just turn it into the normal integration problem, and then we will sort this out later on. Okay, so 10 to the power 5 using the reduction formula, Rn would be 5. So it would be 5 take away 1, that would be 4, and then here 5 take away 1, that would be 4, and then you've got your minus, and then 5 take away 2, that would be 3. So applying the reduction formula, that will then give you this. Now looking at this, apply the reduction formula again. So this time Rn here is 3. Rn here is 3. And remember, you've got a minus here, you've got a minus here. This whole block here is inside this thing here. So applying the reduction formula, on this would be, remember Rn is 3. So 3 take away 1, that would be 2. 3 take away 1, that would be 2. 3 take away 2, that would be 1. So this block here will then become this. And then now it's this times this, that will give us a negative, this block. And then this times this will then give us a positive, this block. Positive, this block. So that will then take us to here. So now, hang on. So now integrating 10. If you forget how to integrate this, then visualize. Well, you should know by now that if you integrate this, it will then give you this thing here. But if you forget, then visualize 10 as being sine x over cos x. Now this is almost the exact derivative of this. So it's going to be natural log. There's a minus somewhere in there. So it would be this cos x, and then you can push this minus into here. That will then be cos x to the power minus 1, which is 1 over this thing here, which is secant of x. So you forget. Well, you should know it by heart, but if you forget, then visualize this, and then this will slightly guide you to the natural log absolute value of secant of x. Well, you should know this by heart. So integrate this. That will then give you this block. So that will then take us to here. So now to integrate it from 0 to pi over 4, 0 to pi over 4, we would put this into here, and this into here, and this into here, and then take away, and then we would put this into here, and so on. So hang on. So when you put this into here, if you can't remember, create a triangle in your mind where the angle is 45 degrees. So if the angle is 45 degrees, then this must be 1. Let's create a triangle where this is 1, this is 1. If this is 1 and the adjacent is 1, then the hypotenuse will have no choice but to be root 2. So when you put this into here, tan pi over 4, tan would be this. Tan pi over 4 is really 1. It's really opposite over adjacent, which would be 1. So this whole block here, 1 to the power 4 would be 1. So this whole block here would be 1. 1 times a quarter, that would be a quarter. And then when you put this into here, remember tan pi over 4 is 1. 1 squared is 1. And then times this thing here, that will be this thing. And then put this into here. So remember, secant is cos is adjacent over hypotenuse. Secant would be hypotenuse over cos. So that would be root 2 over 1, which is root 2. So when you put this into here, secant pi over 4 would be root 2. That will then take you to here. And then when you put 0 into here, 0 into here, 0 into here, it will then give you this. And remember, natural log of 1, natural log looks like this. Natural log of 1 is actually 0. This block is 0. So everything here disappears. A quarter take away a half, that would be negative a half. And then switch these two around, that will then give you this. And then square root, you can imagine the square root as as 2 to the power of a half, and then you can actually take this out here. That would then give you this. So your overall answer would be this. Okay.